Next thing I want to do is look at a remark. For x such that this power series converges, so for an x value such that this series makes sense, what can we say? First remark, if I take a constant k and multiply it by this power series, then I can do the thing that I would want to do if I was only adding finitely many terms. I just multiply k by each piece. So as a sentence, this is we can bring constants inside power series, as long as it's an x such that this power series converges. Second, I can multiply the power series by some power of x. And in exactly the same way, I can bring that inside. And I get x to the n times x to the m. And what do? I add the exponents. Okay, so this is going to be very useful for doing more examples. So let's see some cases. First example. F of x is 2x over 1 plus x. Second example, h of x is 3x to the 4 over 1 plus 5x squared. Last example, g of x is 2x over 4 plus 3x cubed. Okay, so I want you to approach this the same as the last bunch of examples. Find power series representations and decide where these representations are valid. Okay, so let's run through the solutions. First example, f of x was 2x over 1 plus x. So we take out the 2x, we've got times 1 over 1 plus x, which is equal to, from the last example, 2x times this series, which, using the remark, we then bring in the 2 and we bring in the x. We have 2 out in front, and then the x times x to the n is x to the n plus 1. And again, this equality here is only valid for absolute value of x less than 1. So we've successfully expanded f, and we know where this expansion is valid. Second example, h of x was 3x to the 4 over 1 plus x to the 5. Again, we're going to take out the 3x to the 4. We're going to have that times 1 over 1 plus 5x squared. This is equal to 3x to the 4. Following the same vein, we're going to write the second part as 1 minus 5x squared under 1. Now this is equal to, where is this valid? Now I'm going to use the same trick, but to use this trick I need that minus 5x squared is less than 1 in absolute value. That's the same as saying, if I drop the minus sign, then I can take out the 5 and bring it under, so I have absolute value of x squared is less than 1/5, which is the same as the absolute value of x is less than 1 over the square root of 5. So that's where this is valid. So 3x to the 4 minus 5x squared in a geometric series equals 3x to the 4, sum, and equals 0 to infinity, separate out the minus 5, and x to the 2n to the n is just x to the 2n. Now bring in the 3 and the x to the 4. We get 3 times minus 5 to the n, x to the 2n plus 4. So here, the interesting thing about the second example is it's the first example where we've seen where the interval of x where the formula makes sense isn't just absolute value of x less than 1. We have absolute value of x less than 1 over square root 5. So this interval where the series makes sense, i.e. where it converges, can change in size. We've seen that. Okay, so let's move on to the third example. G of x equals 2x over 4 plus 3x cubed. Now let's take out 2x over 4 because we want to use the trick where we have 1 over 1 minus something. So to make that 4 at the bottom of 1, I'm going to take 4 out of every term on the bottom. So I'm left with this. This is equal to, if I have 2x over 4, that's going to cancel one of the 2's, and I just get x over 2 times, same trick, 1 minus 3 over 4x cubed under 1. Okay, now this is a little more complicated. Remember, I want to use the same trick, the 1 over 1 minus x trick. So where is it valid? Well, it's valid for the thing. The thing in our case is minus 3 over 4x cubed less than 1 in absolute value. We do some algebra on that. We're going to get overall absolute value of x less than the cubed root of 4 over 3, which is the most interesting interval we've seen so far. And now I can use this equality. So it doesn't matter, again, we had the case where we had 1 over 1 minus w. It can be whatever you want as long as the size of that thing is less than 1, which was the algebra we've done in the turquoise. Working through more of the algebra and bringing the x over 2 inside using the remark, we have sum n equals 0 to infinity minus 1 to the n, 3 over 4 to the n, a half times x to the 3n plus 1. And there we have it. We have the interval where it makes sense, and we have the formula. Okay, so exercise. This is something you should try yourself. Find a power series representation or expansion of the function below and determine where the expansion is valid. G of x is 2x squared over 3 minus x. Okay, so try this as an exercise. If you want to check your answer, this is worked out on page 11 of the printed notes.